We are going live.
Okay. Okay, I'm pressing now to go live. Sounds good?
We're already live. Hello, everyone. I believe that makes us officially live.
All right, perfect.
With grace and aplomb, as always. Hello to everyone who is already on the stream. As usual, we're just going to wait for a couple minutes here to get everybody all filed in. But, you know, while we're doing that, it's always good to vamp a little, make some small talk. So have either you two, you know, today, obviously, we're talking about the Perseverance Rover, very exciting event that's happening tomorrow. Are you two planning on watching the stream? Because it's all going to be live streamed, which is very exciting.
Yeah, for sure.
Oh, yeah. Tomorrow. I'm excited to just watch the stream and see how successful this landing will be. I'm very optimistic for it.
Yeah, I mean, I certainly hope it goes fine.
Yeah. What do you think, Alexander? How do you think it's going to be?
I mean, I'm putting out good vibes into the world. I really hope that everything goes fine. You know, it'll land beautifully, and we will have no problem whatsoever, and we'll have another wonderful rover on Mars.
Have you picked a landing spot on Mars on the Jezero crater or not?
Me personally.
Yeah.
I think that was a little bit above my head, just a little bit.
Okay.
Got people trickling in here. Wait for the view count to level off a little bit and get started in just a minute here. All right, I would say that it's about that time, so let's jump right in. Hello, everyone. Welcome to Universe at Home. Today we are talking about a very special topic. We're talking about the Perseverance Mars rover coming soon to a red planet near you. That is, in fact, landing literally tomorrow. So this has been a very timely Universe at Home. I'm Alexander Criswell. I am a graduate student in astrophysics at the University of Minnesota, and these are my colleagues.
Hi, everyone. My name is Noah. I'm a junior in aerospace engineering and mechanics, and I'm also TA in the Department of Physics and Astrophysics here at the University of Minnesota.
Hello and welcome, everyone. I'm Andrew Toivonen, and I'm also a graduate student in astrophysics here at, the University of Minnesota as well. not to forget that, but
it's only plastered across the bottom of the screen.
Yeah, exactly.
So without further ado, let's jump right in with Mars. So again, Perseverance is a Mars rover. It is going to, unsurprisingly, Mars. For anyone who's unfamiliar with our nearest neighbor, it is a really fascinating planet because of the fact that it's smaller than the Earth, but it seems to have a lot of evidence for an Earth-like past, or at the very least, a watery past, which, as you all know, is so absolutely vital to life on Earth. So if there's anywhere in our solar system that's our best bet for understanding or finding evidence of life on another planet, a lot of people think it might be Mars. On top of that, it's close. Like I said, it's our nearest neighbor, so there is a lot of convenience. Frankly, it's a lot easier to get to than like Europa, all the way out in the outskirts of the solar system. We're going to give you, there's no need to try to read this entire slide, don't worry about it, but this is a brief history of Martian exploration, and the main point of it is to say that there's been simultaneously a lot for like space missions but in grand total, not very many missions to Mars. There's been on the order of 20 or so, which for putting satellites in orbit or putting a robot on another planet is a lot. We have 20 lenses into Mars from a close-up perspective. And there's a lot more to find out. It's an entire planet, which is, why we're sending yet another one. This kind of breaks down the more recent Mars missions that have been sent out. The ones in yellow are the ones that are currently active. So you'll notice that there is a lander that just landed a couple of years ago called InSight, which is primarily a seismological mission that's trying to understand Martian geology from a seismic perspective, and it measures Mars quakes. Very cool. Curiosity, of course, is another rover that's bopping around and has been since 2012. And then, of course, you see in gray the various other landings ranging from the Viking missions in the 70s to Spirit and Opportunity, both of whom are sadly deceased. Opportunity only as of a couple of years ago. One of my favorite facts about Mars is it is the only planet that we know of that is entirely populated by robots. So we've got yet another robot that we're sending off. It's going to land tomorrow, and this is Perseverance. And this mission has been in the works for a very long time. It was approved back in 2012, just after Curiosity landed. And they've been working on it for the past, 8-9 years. You can see the whole timeline there. We're not going to get into the specifics of it. But all of it has been leading up to a launch that happened in July of last year of 2020. And now, of course, the landing at Jezero Crater tomorrow.
One thing to understand about the purpose of the Perseverance rover and also where it's landing is key to understanding what their main goals are going to be. So the Perseverance rover is going to be landing at the Jezero Crater, which is a crater that is about 30 miles in diameter or 48 kilometers in diameter, for those who like metric. So the important thing here is that this crater used to have some sedimentary sand regions in which apparent water flows are shown when you take a look at satellite imagery. So the entire purpose of the Perseverance rover is to land over there and take a look at the different soil that is on this type of surface, but we'll get to that later. Just for context, this is the entire state of Florida, as you can see here by the lines. And what we want to show here is the overall accuracy that has been improved over decades with Pathfinder, then Phoenix, then Curiosity, and now with Perseverance. This small hole is about 6 square miles. So with that level of precision, we're able to just reach to the crater in an insane amount of time. And with that, we'll be able to get the best answers to the research that's going to be done on the red planet.
So a fun fact that I really like about this mission is that in order to name it, they did a competition and they sent out to a whole bunch of kids, K through 12, who put in their various suggestions and they wrote essays. And of course, as we have mentioned several times, and as we all know at this point, the final name was Perseverance. But we have some favorites of the ones that didn't quite make the cut. My personal favorite is Audacity. I still say that this one should have been Audacity, and if there isn't eventually a mission called Audacity, I will be very sad. I just love the aesthetic of naming a space mission Audacity. It's like, we have the audacity to try to do this science. Has always been very funny to me, and I was sad when they picked Perseverance, although I think it does end up being a very good name. You can see on the screen there some other picks that Andrew and Noah had of their favorites from a very long list of semifinalists. But that's just a little fun fact about the rover that became known as Perseverance. And a name-related fun fact on top of that is that all the NASA scientists call Perseverance Percy for short. So let's talk about this rover.
So let's talk about the Perseverance, the rover itself. Technically, under the JPL laboratory, or just Jet Propulsion Laboratory, it is being nicknamed Percy. And just so you know, this thing is about the size of an SUV. And don't get me wrong, just by this, you can see it by the size of the people that are doing all the research and just making sure that everything is working properly in this rover. Because once you launch it into space, it's gone. And you have to make sure that everything is working perfectly by the time that it arrives. So compared to, for example, a Tesla Model X, it's about half the length of it, but about 35% larger in terms of tallness and also in width compared to the electric SUV. So so let's take a look at some of the goals that the Perseverance rover actually has when reaching the red planet. So the first one is astrobiology. So the Perseverance rover has a bunch of sensors inside the vehicle in order to seek preserved signs of former microbial life, because we've already discovered with the Curiosity rover that water was once present on the red planet. So if we can prove that there was also microbial life on Mars, it'll be an insane landmark in terms of the astrobiology field. The second one is regarding the climate. So we're going to be looking at different habitable environments in the red planet and see if any of those regions are actually fitting for later missions when humans go to the red planet. Thirdly, we're going to be talking about the geology. So the rover has a bunch of drills inside the Perseverance rover, and what it's going to do is just collect different samples so that the landscape is a study, and then reveal the region's history and see how much the land has evolved over the millions or billions of years that the red planet has been around with us. And the last purpose is to prepare humans to go to Mars. So the Perseverance rover has another sensor that is going to be used to test technologies that will help sustain human presence on Mars and possibly lead us to an interplanetary civilization. So these are all the sensors that the Perseverance rover has. So first off, we have here obviously the SuperCam. So it's one of the 19 cameras that the Perseverance rover has, and this one is just analyzing the terrain at a super precise resolution, so that we can get like precise imagery of the red planet. We have META, which is the weather station, so that we can determine how the weather is on the red planet. We have MOXIE, which is an in situ research organization inside of the Perseverance rover, which is going to focus on capturing carbon dioxide and then turn it into oxygen. And this is one of the main purposes that is being researched right now in order to convert the Martian atmosphere into one that is fitting for humans later on when we reach Mars. Also, we're going to be taking a look at Sherlock over here, which is an ultraviolet spectrometer. So it's just going to analyze the different components and different materials and elements in the Martian soil, so that we can see what type of materials could be useful for later uses when humans go to the red planet. And it also includes an X-ray spectrometer. There's a bunch of sensors in here. It's a lot to cover, but trust me, it is insane. But also, these are not the only things that the Perseverance rover has. No, it also includes a helicopter. Yes, a helicopter on Mars. And we have named it Ingenuity. This will be the first time that a drone flies in another planet and even in another celestial body. Like, it's considered it as Wright's brother moment. So the entire thing is about 4 pounds or 1.8 kilograms. That's the weight of a 16-inch MacBook Pro. So all of this is going to be lifted by these two rotary blades, which are 35 grams each. So how are you able to do that? You rotate it at extreme velocities. For example, to take it into perspective, a helicopter is able to rotate its blades at about 500 rotations per minute. These blades are going to be rotating 5 times faster than that in order to be able to be lifted across the Martian surface. And it's going to be able to fly for about 90 seconds each flight. It's going to be working within a month from now, but the main purpose is to ensure that drone flights could be actually feasible to do in the Martian atmosphere, and to later use it for drone transportation if we once we go to Mars.
So of course, need I say it yet again, Perseverance is landing tomorrow. And so I figured that we would take a good bit of time to walk you through exactly what we are going to be seeing tomorrow. You don't have to read all the little bits that are on this diagram because I'm going to break it down step by step. But it is quite important to know that we call this the 7 minutes of terror. This is an actual name that the NASA scientists call the descent and landing onto Mars because of the fact that it takes about 7 minutes to get from entering the atmosphere to landing on the planet proper, but it takes 11 minutes to get a radio signal from Mars to Earth, which means that by the time we hear anything about the rover even entering the atmosphere, it is already landed. And any sort of landing procedure has to be entirely autonomous. The rover has to land itself without any input from mission control whatsoever, because we won't even know if it's run, we won't even hear that it has entered the atmosphere until it has already done the entire entry, descent, and landing. It is out of our hands, and when I say our hands, I of course mean the very talented mission scientists at NASA. So we start, I've said this a couple of times here, but we start when we enter the atmosphere. Right now, Perseverance has positioned itself to be at the proper angle to enter Mars's thin but very extant atmosphere. And it is heading towards that atmosphere at about 12,500 miles per hour. It is hurtling through space, which of course is the only reason that it could get to Mars, which is a very long way away, in any reasonable amount of time. But running into things at 12,000 some miles per hour is very bad for you. So we need to slow that down a little bit here. Just going through the atmosphere itself is going to break the rover, break, B-R-A-K-E, not destroy, but slow down the rover to a mere 1,000 miles per hour. So really no problems at that point. You're dropping by a factor of about 11,000 miles per hour, but you're still hurtling along at entirely too fast. I, for one, would not like to be driving my car at 1,000 miles per hour. During this process, all of that excess energy will go into heating up the heat shield, which will get up to a whopping 2,370 degrees Fahrenheit. But because of its insulation, the rover will be sitting pretty at room temperature. Something that I thought was really cool when I was reading about this is that you're going through an atmosphere and it's not all the same. It's not these flat layers like we like to pretend it is sometimes. But I mean, if you look up, I mean, not right now, it's dark out. But if you looked up during the day, you would see clouds and there are air currents and all sorts of things. And these also apply to Mars. Mars's atmosphere is not perfectly smooth. There are small atmospheric variations that the entry capsule is going to be going through. And with that precision level that Noah talked about earlier, that would throw off the rover's ability to actually land within that tiny 6 square mile radius. So what they have built into the entry capsule are all of these tiny little micro thrusters that, again, completely autonomously are going to be correcting the reentry course in real time to keep the capsule pointed at its landing zone. Second stage, we've gotten through the upper atmosphere. We've slowed down from 12,500 miles per hour to 1,000 miles per hour. And now we're finally going slow enough to deploy a hypersonic parachute. What you see on your screen there is a picture from a test of the very parachute that will be being used at about 7 miles above the Martian surface. This parachute will be triggered by a new range trigger technology where the rover will go, okay, I am perfectly 7 miles above the landing zone, time to hit the parachute. And that is going to drop Percy down to a mere 200 miles per hour. Still completely unsurvivable, but you know, it's a vast improvement. Finally, and this is just the coolest thing, the word sky crane. It has a sky crane, which I find absolutely fabulous. The rover just casually at about 6,900 feet will activate its own little jetpack with 8 different micro rockets that will fire off and slow the rover down to its actual landing speed of a very comfortable 1.7 miles per hour. During this process, as it's slowed down and starting to drift downwards under rocket-based control, the rover will scan the area of the of Jezero crater and figure out, one, where it is, compare that to a preloaded map of the area that the scientists put in well before this point, and then say, okay, we have some designated safe landing spots that are in this 6 square mile area. That's still pretty big. Which one am I closest to? What's the safest place that I can get to? And then in the process, it's going to fly itself over to the best and nearest landing spot that is available. Again, all on its own. It needs to be able to scan the landscape, compare it to an actual map with hazardous locations and safe locations mapped out, and then fly there without any human interaction whatsoever. After that, it will do this amazing maneuver, and why it's called a sky crane, where the jetpack sky crane thing will detach from the rover and lower it on cables until it touches the ground and it can detach the cables. And then on the NASA website, they say it will, the sky crane that is, after the rover has been nicely and gingerly set down on Mars, the sky crane will perform what the official term is an uncontrolled landing, AKA it is going to yeet itself sideways and crash. But the important thing is that it is going to yeet itself sideways so that it crashes well away from the rover and will not harm it in the slightest.
Just a reminder, it's not just yeeting itself and it's not going to be destroyed. It's just a rapid, unscheduled disassembly. Just that. So, as we were recapping before, it's going to take about 12 minutes for any type of communication from the rover to reach our terrestrial surface. So by the time that the 7 minutes of terror happen, the Perseverance rover is already going to be on the red planet, either operating and functioning or completely destroyed. That's why it is very important that all the procedures are done, well calculated, in order to have the rover just on the red planet. So think about that. And in the end, that's also going to be applied to future human missions as well, in which communications are going to be taking a long time. So it's just going to be ensuring that the population that is like working in said spacecraft to just make sure that they have all the maneuvers possible and well planned so they can land on the Martian surface.
So after all of this talk about how Perseverance is going to be landing on Mars and the fact that it's happening tomorrow and the fact that we obviously think this is extremely cool, you might be asking yourself, well, maybe I want to take a look at this. Where can I watch it? Well, we've got you covered. This is where you can watch it tomorrow. Obviously, these links, you cannot click on them. But my colleague, Andrew, is about to throw these, the link to the live stream schedule that NASA has put up in the chat. And he can take, or whether you can take and follow that, and they've got events going all day. You can hear even more about Perseverance. You can hear the actual NASA scientists talk about their rover baby that they care very much about and the cool science that it's going to be doing over the next couple of years. And that link is in the chat right now. So you can feel free to check that out so you know exactly where you can watch it tomorrow. Again, just a reminder that the landing itself will be happening at around 2:55 Central Standard Time. That's where we are, so that's what I'm telling you, that you can convert to wherever you are. And that's when we're going to find out, for good or for ill, whether or not Perseverance has made it to the surface.
Oh my gosh, I forgot for a moment. Okay, so some quick fun facts that are going to happen with the Martian rover that I think were pretty much interesting is that, first off, as I mentioned, 43 samples in total will be collected in tubes and stored in the Perseverance to later return those samples back to Earth. So the entire purpose of this is that we're just gonna be storing already like pieces of the Martian soil into the Perseverance rover, and we are going to, it's just a way of saying that we are going to Mars. So with that, we're just going to be able to just direct all of our resources to reaching the Martian surface, gather these samples, and then return them back to Earth so that they can work with state-of-the-art technology and better understand the composition of the Martian surface. And also, another interesting fact that I think was pretty cool is that Ingenuity is a helicopter that is not going to be like just flying in the same conditions as it is going to be on Earth, because it's going to be flying at 0.60% the air pressure here on Earth. So take a look at that. Imagine that. That's near a vacuum level. Because of this, engineers have been able to work their brains out to just put the system under a vacuum and make sure that it'll be able to rotate its blades fast enough so that it could be lifted off in the Martian atmosphere. How amazing is that? And lastly, the Perseverance rover is not going by itself. It's actually being joined by other equipment sent from different countries here on Earth. And it's going to be one from the United Arab Emirates, which is the HOPE orbiter, and also the China's Tianwen-1 rover. All of these have different purposes, of course, but all in all, it's just a collab. It will be collective effort, I would say. So the entire idea is just to understand Mars, the red planet, better. And with all of this taken into account, you can obviously obtain much better results of what could be found on Mars, since it is our next destination for our multiplanetary species.
One last fun fact that I personally get a really big kick out of. My name, is about to go rocketing down onto Mars, which is very exciting. A while ago, NASA opened an opportunity for people to submit their names to be put onto these three, I'm pointing to it like you can see me, on these three where that red arrow is pointing, these three tiny little microchips. And all of the 10 million or so names were engraved on the silicon chips with an electron beam, and the names are something like 15 microns high each, so extremely small, but they're there, and they sent me a wonderful little boarding pass since I was going along with the rover. And so I'm on there. Well, my name's on there, along with you can see below it is a nice line art drawing of the sun and Earth and Mars. Kind of in the style of the line arts that were put on to the Voyager spacecraft, if you know anything about those. So I get a kick out of that. They're also still doing it. Clearly, you can't put your name on Perseverance, as Perseverance is a very long way away from here at this point. But they have an open opportunity to put your name on whatever the next Mars mission ends up being. And Andrew can throw that link in the chat as well. So with that, we are going to close the top portion of this Universe at Home and open the floor for any questions that you may have. It looks like we've got a good couple in the chat already, but if you've got any questions about Mars, about Perseverance, about random space things, we're something in the vicinity of experts, depending on what you ask us about, and we will be happy to answer your questions. So feel free to just throw those in the chat, and then we'll pick them up as we go. Andrew, do we have any already in there?
Yes, we do. So excellent. First of all, we have a really great question here. Why was Jezero crater chosen as the landing site? And so actually, Mars, I don't know if anyone knows this, but Mars, we think, used to be a wet planet with water and flowing rivers and lakes. And I'm actually going to share my screen here and show you this really cool image.
I will stop sharing mine.
Yeah, so if you want to, so we think that it was actually the location of an ancient river delta, and I'll show you this here. So this is the landing site here, and you can see that this is actually what, very much looks like, right? A canyon carved by a river. So that is essentially the reason why we've chosen this. The hope is that, microbial life, once lived here, developed in, this lake or crater, because this canyon and the river would have flowed through here, carrying minerals and whatnot into this crater and this possible landing site. So you can clearly see the river path and the delta, right? And so that's essentially why Jezero crater was chosen. So that's a great question.
I have a little bit of a tag team answer to that, because you reminded me of something that I read a little while ago. That sort of river delta formation, and looking at the delta part on Earth, we have seen that in geological formations like that, you can get fossils of microorganisms preserved for billions of years, or millions of years rather. And if there were microorganisms present in Mars's distant watery past, they likely would have, if they were there, they likely could have been fossilized. So there is a chance, however slim, that there could be fossilized microorganisms in this spot, which is part of that big draw.
All right, so I think we have at least one more question. Let me take a look.
Looks like we
have a couple more.
Next question. How will it return to Earth? Someone else want to?
Oh, I think that was with the samples. I remember that one coming in.
Yeah, that was with the sample section. So the Perseverance rover is not going to return to Earth. It's only going to be able to store all the 43 samples into the inside of the rover. It has, one cool thing that I haven't mentioned here is that even though it also has, it's shown that it has a mechanical arm, on the outside, it also has a mechanical arm on the inside. So the samples are gonna just be picked from the Martian surface, and they're going to be placed into different chambers inside of the rover. So all of the samples are just going to be stored inside, and whenever a spacecraft with humans comes over, the samples are just going to be picked up and then sent back to Earth so that they can be worked with for laboratory purposes, of course.
I believe the official NASA wording, which is about all they've said on the topic, is a future sample return mission, which what is entailed in that is either human spaceflight to Mars, which one, so cool, or like a robotic sample return mission, which is also amazingly cool, going there and back again to make a hobbit out of a spacecraft. Is an extremely cool idea when it comes to the red planet.
Right, and as you may imagine, a return journey would not be easy. You'd either have to bring the fuel for the launch with you there, which would be a lot of weight, or somehow create it on the planet. So that's kind of the problem there for just being able to bring the rover straight back. So next question, how was the helicopter recharged?
Okay, that one is a question for me. So the Ingenuity rover has a solar panel on top of the entire system. So you have the two, I don't know if you can share the screen, actually, Alexander, and go back to the Ingenuity
I can't.
slide.
Let me do that. Ingenuity. If I can find it.
Yeah.
There we go.
There we go. All right, sweet. So as you can see here, there's a top panel in which it's moving. Those are the solar panels of the entire system. So these small plaque at the top is going to be able to recharge the battery that it has inside of this small box in here. So it's going to be about a 2,000 milliamp hour battery, a little bit smaller than the battery of an iPhone. So, and it's just going to be able, but with that, it's enough so that it can fly for like 90 seconds. So, yeah, and it's hope that it will fly for about a minimum of 5 times, I think.
Awesome. So on to the next question. Do you three or anyone else at the U have an experiment on Perseverance?
I can take this one. So as far as I know, none of us three, unless one of you two wants to speak up suddenly. And as far as anyone else at the U, I don't know, but which is always dangerous territory. But we do have a member actually of the geology department at the U, which during normal time shares a building with the astronomy department, who is working with Curiosity and does work with Mars rovers and with Martian geology. So her name is, I want to say Dr. Valerie. I can't remember her last name. She's really cool. I've been to a seminar that she gave a talk about the geology that they've been doing with Curiosity. But yeah, so my guess is that yes, there is at least a person at the U who works on Martian geology, which to me says they will probably work with Perseverance at some point.
And then the next question, are there any planned interactive activities between the US and China rovers?
I don't know. Does anyone else?
I'm unaware of.
I'm unaware too.
So that there could be, there could not be. We don't know. Sorry.
In the end, it's just under like for the sake of diplomacy, or if they were like just leave all the conflicts behind and just go for research purposes, that'd be incredible, and that would be the most optimistic outcome. But I don't know. What do you guys think?
Well, right. So ideally, most of the data, should be, published eventually. So there should be, scientific examination of, both the rovers' data. But as for kind of, collaborative missions on Mars between the two rovers or something like that, like I don't, not that I know of. So
I will also say that in terms of actual physical interaction, the two rovers are landing on very different parts of the planet. So they will not be in physical, like close proximity to each other. And for good reason, like there's not a lot of point in having two rovers in the same spot. You know, you can maybe do like a return visit 20 years after the fact to see how things have changed, which could be interesting. But since there's so much of Mars that is completely unexplored, as a scientific community, the best bet is generally to explore different places and varied biomes.
And then the next question is, what is the landing time of the rover in expected landing time in Central Time? And
2:55
that
Central.
is 2:55, yes, yes. Central. And then what is the UAE orbiter observing, and what is their mission objective? And it looks like their mission objective and is essentially to study the weather and the dust storms on the planet. Does anyone else know anything more about that?
That's basically the entire purpose. Just going to be like flying through the lower atmosphere in order to just examine the different dust particles that come from dust storms and evaluate the different changes in the climate, because also the climate in the Martian atmosphere is a bit erratic. Sometimes it can have like no sandstorms at all, and sometimes there has been one event back in 2018 that covered the entire planet under a sandstorm. So this behavior is erratic, but so the entire purpose is to just observe how often and how sudden these changes are.
So next question. What will they use the oxygen for that is produced by MOXIE? Or is this just a proof of concept to see if they can convert Martian CO2 to O2?
So I can take this one. It is primarily just a proof of concept. The idea is there are a couple of pieces of technology on Perseverance that are like this, where do they have like some auxiliary purpose? Maybe, but the main thing is, well, can we convert can we convert carbon dioxide into oxygen? Because that is such a vital thing to be able to do if you want to, put humans on Mars for any extended period of time.
Right. And so that's all the questions for now, but we have a couple more, things we want to show off here, a couple simulations here that, show you a little bit about essentially the entry, descent, and landing of the probe. But if your questions come up, we should still have a little bit more time at the end, so feel free to throw them in the chat. So I am going to show a couple of things. First of all, these are a couple of things that you can actually find right on NASA's website. And before I do that, before I pull them up, I'm actually going to drop the links right in the chat for everybody. Because these are things that you can take a look at outside of this and for other probes and whatnot. So let me share my screen now. So this first one here is allows you to see the essentially the whole solar system. But in this case, you're actually able to search for the mission. And in this case, it's called Mars 2020, and that's the whole probe here. Let me pull this up. So we'll just load for a second, and you'll get a quick overview of the spacecraft. And the reason this is cool is because you're able to not only spin it around, take a look at it, but you can also scroll down and see details about traveling to Mars, its velocity and whatnot. And also what I thought was really cool is actually compare it to other probes. So something like, you can compare it to something like Juno, which was a Jupiter mission. You got New Horizons out here. And we got Pioneer. This was also a Jupiter mission. And then you can also just compare it to, Voyager is also on there. Voyager was actually heading towards the outer reaches of the solar system. And you can also compare it to the size of, like a person, or I think they have a school bus on here as well. So there's a few different things you can look at on there just to, check out, the rovers and actually, or the spacecraft, sorry, and how they compare to certain objects. But on top of this, you can actually take a look at the trajectory of the spacecraft, which I think is really cool. So you can see here how actually the trajectory here, you have to go and intercept the orbit of Mars. So you see how you got to kind of, follow the orbit there and cut off Mars so that the two come together right on their trajectory, which is pretty cool. And on top of that, there is also another site here that is on NASA's website. And this is actually going to show off the entry, descent, and landing procedure. And this is really cool. So let me just pull this up into full screen here.
This will be fun. We'll get to see all
Yeah.
the little bits and bobs that we talked about earlier.
Yeah, Alexander covered all this, and now we'll actually get to see him in animation. So for now, I'm going to speed up because we got to get a little bit closer here, but I'll slow down as we get closer. So first, we're going to be preparing for the cruise stage separation, which is where it's essentially shedding its outer solar panels and sensors and all that stuff, fuel tanks that it's not going to need for entry, descent, and landing. So as you'd suspect, there's a lot of things that it took to get it here, and it doesn't need those anymore for its landing. Obviously, the goal here is to get the rover down to the ground. So as we're coming in here, you'll see that it'll even tell you the next phase here, which is going to be de-spin. And I will slow up once we get there, but buffering a little bit. But the de-spin is actually relevant because, we just lost our cruise separation. That was a little too fast. It went earlier than its time right there. But the de-spin is actually relevant because the spacecraft spins on its trajectory on the way there to help stabilize it so that it continues traveling in the desired trajectory. And then once you're coming into the atmosphere, you're going to want to de-spin because if you remember here, the goal is to get a rover down to the ground, and you don't want the rover spinning in circles while it's dropping in its parachute or coming down to the ground, right? So that was the de-spin phase. And then now that you've despun, you're going to be doing these ejecting these cruise balance masses, which had a similar thing to what was going on with the spin. It was essentially to balance them in their they balanced them in the space flight, right? But you need to eject them now because they're trying to, as it says here, create the desired lift to drag ratio. So this has to do with aerodynamics in the atmosphere. You need the spacecraft to stay level and not start tumbling and flip over, because that would be essentially a disaster in your 7 minutes of terror. So as we're coming in here, we're going to get to the next entry interface point. I don't want to go too fast here. Right. So now as the spacecraft is entering the Martian atmosphere, it is slowing down, and that's from friction and air resistance. And then it will eventually, now this is what Alexander was talking about, now its guidance has to start kicking in, because as we talked about, we cannot communicate with the spacecraft. So this is where it needs to start making sure that it's balanced, and it fires thrusters to make sure it stays level. Because again, if this starts tumbling, it's all over. And so you really, this has all got to be automated, and all these sensors are kicking in and making sure things are stable. So as we're coming in, I'll speed it up a little bit. And now up ahead too, you can even see the landing site. It's starting to show up on the map here. So we still got a ways to go. About to go to the next phase here. And now we see here again, so now the computer is trying to fire thrusters and adjust its trajectory so that it can hit the landing site as accurately as possible. Again, there's a specific reason we chose this landing site. We want to be right in that river delta. So we got to make sure that we hit our target. There's a lot that goes into this mission, obviously, and want to make sure that everything goes as planned. So I'm going to switch this auto camera now so we can get a better view. And here you see it coming in through the atmosphere. And so again, now they have an acronym, SURFER, I like to say, straighten up and fly right, and eject some more balanced masses as it's getting into a thicker area of the atmosphere, right? As you go down, further down, there's more and more air, and it sets the angle of attack, which has to do with air resistance. And now the parachute deploys, and remember, Mars has a very, very small light, atmosphere compared to what's on Earth. So this needs to be, a very, very large parachute for this small spacecraft. And again, there have to be all these automation. There's a range trigger so that it deploys at the right time. Because again, we can't tell it when to deploy. It all has to be automated. And once we're slowing down and in the atmosphere, you can actually eject the heat shield, and that will essentially expose now the rover. So the rover was protected by a heat shield for its journey. Primarily, this was to protect it from, entry into the atmosphere, but also protect it in space from, dust and, small, asteroids or whatnot that it could have encountered. And here it talks about cameras and instruments begin taking data. So this will be our first glimpse, hopefully, of Mars here. And if you see here, it even tells you got one minute to touchdown. So let it this next phase. And it's going to shift the camera here. And so now this is where its actual cameras. Oh, and I don't want to skip past this because this is a pretty cool part. Is that if we talked about you had to have the onboard cameras taking pictures, and then there's an onboard computer that is actually re-correcting the course for safer landing. Again, this is all automated. So it is taking these pictures and it has maps uploaded on the rover actually that it's comparing it to. And it talks about it here. And so now it says that it has found a valid solution. This is the simulation saying that it has found its valid solution and it knows where it is trying to land. And you can kind of see here the river delta and the crater that we've talked about. So if I slow it up too, I can actually spin this around. We can take a look at stuff. You can see the rover underneath there. So you see that's what, that's how this looks, right? The heat shield has been ejected and you got the parachute on top and the rover's underneath. So we are getting ready to eject the rover, if you remember from Alexander's talk on that. So we're going to shift the camera around and now you can see the rover underneath. And it says back shell separation. This is where the rover is going to detach from the parachute and fire its thrusters. So it's trying to reduce vertical velocity, reduce its speed, and eliminate any horizontal velocity. We want it to come down nice and slow, nice and steady, nice and flat. We don't want it to obviously have a rough landing. It's a very expensive piece of machinery, and we need everything to go as planned. And so then as you get close, we'll fire the rest of the thrusters and hopefully slow things down enough for a nice soft landing. Touchdown in 30 seconds here. Fires the last bit of its thrusters to stabilize and really come down as slow as possible. And you can see the parachute just drifting down. And then it lowers the rover down, and the thrusters and the rest of the equipment will actually jettison away and just burn their fuel, which you'll see from this, which is pretty cool because you want to essentially get that away from the rover, out of the way. We don't need that. All of our instruments are actually on the rover itself. And then essentially we're into operations where we can, enable all of our, cameras and sensors, start taking data, and hopefully relay a, successful landing signal back to home base. And so again, this is something that I linked in the chat. You can take a look at it. You can play with this. It's pretty cool. And, it gives you, an idea to some of the stuff that, you'll kind of be able to see in the live stream, but obviously this gives you a simulated view of the machinery and what's exactly going on there.
Well, that was really cool. I didn't get a chance to look at this before we went live, and I'm glad I didn't because I got to experience it in real time with everybody else, and that was a lot of fun.
Yeah, it was.
It does look like we've got another couple questions in the chat before we wrap up real quick here. The first one from Stephen asking, how far away from Perseverance will Ingenuity fly? And I knew the answer to that one. It's going to fly about 50 meters, so 150, 160 feet out and then back before it recharges for its next little jaunt. Its planned mission duration, I think, is about 5 little jaunts over 30 days or so, and then they'll just kind of keep using it until it breaks, which is how things go with these rover missions. We also have another one from Dick Hendrickson asking why the United States, United Arab Emirates, and Chinese probes are all arriving at about the same time. Wouldn't it be better to separate them by a few months to get a broader view of Mars?
I think I can answer that. So, okay. So, the reason why all of these 3 spacecraft are being launched at about the same time is because they are going through something we call the Hohmann transfer orbit. So this type of orbit allows the entire, the most efficient way to just send a piece of equipment from one planet to another. And why we do it is because it's one of the most fuel efficient, and in the end, it allows us to reach the planet at a certain time. It's not the fastest one, but it's the most energy efficient. So all of these space agencies decided to just do their launches at this time, during the period of Yeah, June, July, August, so that they could arrive at about the same time to Mars during this period in February.
Yeah, and what you got to keep in mind here, and I can actually share back to my my view here, the solar system, is that Earth and Mars are just two planets going around the sun. It's not like Earth and jumping to Mars is a straight shot and you can just launch something just like that. You have to launch it along the orbital path, and you have to time that orbit. So you have to wait for Earth and Mars to be lined up per se, so that when you launch your probe, it's going to follow its trajectory and reach Mars and intercept the orbit. Essentially, that's the goal here, is to intercept its orbit. And so there's essentially launch windows from which that is the easiest and the fastest, most efficient to do that. And that's exactly why.
All right. And if it doesn't look like there are any more questions coming through on the chat, I think that is Universe at Home for the night. We've made a good hour of it, which is about what we try to go for. So thank you all for coming. Thank you, Andrew and Noah, for presenting and helping out with everything. Wonderful job. Have a wonderful night, everybody. And don't forget to tune in to the landing of the Perseverance rover tomorrow. And cross your fingers, because I, for one, want cool new Mars science. All right. Have a good night, everyone.
Thank you, everybody.
Thank you.
And we are now